It's Julien. Julien. this this talk is an open source project. PoWA. PoWA. Say PoWA. Uh, I think it's talk about maintaining performance. Let's welcome.
Uh, Good morning, everyone. So, while I was waiting, the first thing I did was to start a bunch of containers to set up a whole PoWA stack. So after the end of my talk, if I have a bit of time left, we can look at the actual UI, which is more interesting than a bunch of slides and pictures. So today I will talk about how you can use PoWA to improve performance on your Postgres servers, and also talk about some new features of PoWA version 5. Let me introduce myself first. So my name is Julien Rouhaud, but you can call me Julian, way easier to say. I've been working on Postgres since around 8.2 or 8.3, so in 2008. I'm a major contributor. I've been working as a developer and a DBA. So I've been working on contributing to Postgres and some additional tools and extensions, so PoWA, which I'm talking about today, also HyperPG and some other tools. And now I'm working as an engineer at a Nile database. First I will introduce a bit PoWA to let you know what exactly it is and how you can use it, and then I will focus more on the actual components that it's used underlying, how to use it, and how it can help to improve the performance. So let's get started. So PoWA actually stands for Postgres Workload Analyzer. So it's a PostgreSQL-centric tool that's designed to gather a bunch of data sources. So it can be extensions, it can be like pgstat views and other data sources. It's designed to fetch all the data sources at regular interval, store them in an efficient way. So it uses aggregates of rows, so it can be compressed transparently using the toast mechanism on Postgres. And then a UI that you can use to display all the data in some convenient way, highlight what can be the bottlenecks or the problems, or even in some case actually provide some recommendation on what you can do easily to help improve the performance. So another way to say that is the goal is to show you how your application is performing under the hood. Usually in most companies I've seen, you have on one side you have the developers, so they work on part of the application, so they know a few of the queries but not everything. So they know what they want to do, but they don't necessarily know what other people are doing. They also don't necessarily know what the full size of the data set. So if you try the query and it's like very fast because you have 10 rows, and then suddenly in production you have 10 billion rows, it's not the same, but the developers not always know that. And on the other side, you have the DBA or the SRE, and they see all the query happening, but they don't know what the developer actually wanted to do. And they can sometimes improve it, but they don't really know what was the intent behind it, and if they can rewrite the query or not. So sometimes it's difficult to have those people work together. So the goal of this tool is to have a common way for everyone to see the same thing and work together. So it helps you to focus on the problem, like what is slow, when it was slow, and as I said, suggest optimization. So the kind of question this tool can answer is like, someone comes to you, say, yesterday at 11:30 it was slow, why? You can look at the graphs and it should highlight you what was the problem. We'll see that. So if you want to install it, you have two modes. The first mode is a local mode, so everything is self-contained. So you have like your whole instance. You have your PoWA database with the extension, a BG worker that's running on the server and stores all the metrics locally. So on top of that, you have your own database with your application and everything, and the UI that fetch the metric from the DB, and sometimes can access to the database and show the metrics. So it's a bit limited because since it's self-contained, it cannot work on a standby because a standby is read-only. And also, if your server is already a bit saturated, it would just add extra overhead because it's storing everything on your instance. So that's why we introduced the remote mode in version 4, so like a few years ago. So it's mostly the same components, but a bit stored differently. So now in this mode, you have like a dedicated instance, which can be any Postgres server, where you store all the data. And you still have the stat extension on your production server or whatever server, but they are only used to read the data from. So select star from pgstat statement, pgstat, whatever. And instead of the BG worker, you have a collector daemon that connects to all the instance and stores the data on your dedicated repository server. To install that, you have multiple options. So it's cloud ready. You have container images for all major versions since Postgres 9.6 to Postgres 16. Once Postgres 17 will be flagged as .0, it will also add a version for this one. We also have a compose file. So the PoWA suite that I just spawned was one of the compose files in the repository. And if you prefer a more traditional way to install it, you have packages like RPM packages, yum packages. You have also Windows installers for multiple extensions. And you can always compile from source because it's open source. Okay. Any questions so far? No. So let's dig into the components and how it looks like and how to use it. So with the version 5, we added a lot of data sources. So you have all of that. I definitely not have enough time to introduce everything, and it will be a bit boring if I did. So just remember that it's only like the main modules and extension I'm introducing. The first thing I will talk about is DB and instance modules. So almost everything in PoWA is optional. You can activate or install whatever you want, and everything will work magically. So I have two kinds of modules you can use. One is the global modules, which is like some of the pgstat views that shows information about the whole cluster. So for instance, pgstat activity, pgstat bg writer, or pgstat replication. Or you also have like a database local information. So you have the catalogs, which PoWA now snapshot. So you can see from the UI which was like the list of tables and columns you have at any point in time. You also have here in this case the pgstat user functions. So it's statistic about function execution, which are stored along the source code, and that is the same for the table and indexes. So if you enable the pgstat user function and you have function called, you have this kind of graphics on the UI. And so here it's a very artificial example. It's just used to show how it can help with like something very obvious. So I have a list, like I have two functions. So the outer function is what your application may call, like somewhere in your application you call this function, and this function underlying call another function, which is the inner function. So if you just look at the cumulative runtime, you see like both of those functions have been running for like 2 minutes and 27 seconds. So naively you say like, oh, my application called outer, and it lasts for 2 minutes and 30 seconds, I should try to optimize this one. But looking at this data source, you see that the outer function was only running for 8 milliseconds, and all the runtime was actually in the inner function. So that's not F outer you want to optimize, that's the F inner. So the UI show you that very easily. And as I mentioned, it also captures the source of the function, so you can see why what was slow. So in this case, the outer function, you can see that there's no point optimizing it because it only calls, it's a wrapper on the inner function. pgstat statement. Has anyone already used pgstat statements or know about it? Few people. So it's the only mandatory extension in PoWA. That's because it gives you the query normalization and the unique identifier that everything else relies on in the project. And it also gives some general metrics that are quite interesting. So here is an example of the UI for the global instance view. So on the upper side, you have like a bunch of graphs that shows what is happening under the hood. So here you see like the execution time. So we have the average runtime, the number of query per second. We also have what is a runtime. It's some kind of a load average, but transposed to an SQL way, which is how many seconds of SQL you are running every second. So if you have 10 CPU, you can run 10 seconds of query every second. You also have the hit ratio. I will talk about the metrics a bit later. And yeah, so a lot of information are available that can help you to narrow down the problem. Just below this graphs, you have a grid. So it's the same information, but instead of being snapshot every few minutes, it's like globally what was in the period you are showing. And as you can see, like it's sorted by the number of temporary blocks written. So in this example, what maybe my problem was that I have too many temporary block file use, and I want to know why. So if I just sort by the the metrics I want to, like the resource that is problematic, I can find the culprit, and it should be in the TPC database. So that's a very important part of the UI. It's a drill down approach. You start at the global level, and then you try to drill down and go a bit deeper to see where it is. So from the instance, you can find the database. From the database, you can find the query. From the query, you can find the predicate, and so on. So let's say you drill into the TPC database. You go to another view. So it will have the exact same graphs, but this time filtered by this database only. And then instead of having a bunch of databases, you will have a bunch of queries. So you have the exact same information, a bit more details. For instance, the I/O time is now split in the read and write. On the one before, it was only like accumulated. And the list of queries, and if you hover, you see the whole query. So you can also, here I chose to sort by plan time to see which one is the slowest to plan, but I could choose to sort by temporary blocks. Oops. Another extension is pgstat kcache. So the K from kcache is from kernel. So it's a wrapper on top get R usage, if you know the system call. So it provides statistics from the kernel, which is like the CPU usage, so user CPU and system CPU. The physical disk access, which is something you usually want to avoid in a database, but because that's really slow compared to everything. And with this extension, we can also compute a real hit ratio. Usually with pgstat statements, all you can see is like the what was in the shared buffer outside of the shared buffer. But if it's outside the shared buffer, you have no idea if it was in the OS cache or if it was on the disk. So it's really hard to optimize. With the extension, you can distinguish both of them. And some other system metrics like the context switching and others. So here it's on the per query view, and in the main graph, you have an I/O widget tab, and you see some extra information. So here I'm showing what I was talking about, which is the system cache hit ratio. So I highlight what was actually in the system, what was in the OS cache, but you also have what actually hit the disk and what was in the shared buffer. So if the disk hit ratio is very high, it means you need more RAM, or you need to find a way to optimize the rest of your queries. It's also show like the read and write time and the physical block access and the CPU. So here, for instance, on the CPU, you see like the red one is that's user time. So if on your server you realize you have 30% of user time, it means you have way more queries that your system can handle. So it wasted time doing like context switches and other stuff rather than executing your query. So in this case, it shows you that you probably want to lower down a bit your max connection or put a pooler or something to avoid wasting resources. PG track settings, so another extension which tracks the change in the GUC, so the configuration, either at the global level, so if you change your postgres.conf file or if you do an alter system, and also on the per database or per role. You can do like alter database sets workmem equals something, and it will be on a per database only. Also tracks the instance restart. So here you have a graph where so the average runtime was like about 1 second. And then at some point, the workman changed from 64 kilobyte to 100 megabyte, and now everything is suddenly faster, which is usually intended. So it can help you find if a setting you changed actually help your production, or on the other hand, did something worse. So you can roll back your change. So it helps you to find out this kind of problems. PG weight sampling, another extension. This one is by Postgres Pro company. So it provides a weight event overview with a high frequency sampling, because there are just too many weight events to actually get every one of them. So the frequency is configurable. By default is 100 milliseconds, which usually is way enough to actually pinpoint some problems. So here it was on a global instance level, and we can see like the sum of weight event again by descending order, and you can find the weight event and the associated database, so you can drill down. So for instance, if you have like I/O issue, you can find like maybe, okay, this is probably on the TPC, you have too many I/O weight events. And you can also have it on the per query level, so you see what was happening. And here we have a bit of data file read and data file write, so maybe a bit more RAM would help on this one. PG QualStat, another extension. This one provides statistics on the predicates, so the where and the join clauses, with a lot of information, like what was associated relations, the type of scan, if it's like a sequential scan or index scan, selectivity, and some other information. So again, on a query view, you see you have like a query that's quite not really difficult, but it can extract all the where clauses, and it shows some interesting information, which is two predicates are executed very often and filtering almost everything. So if you have, as a DBA, you see that, say, oh, this looks like a good candidate for an index. And the UI does exactly that. It say, oh, yeah, this predicate are executed very often, filtering a lot of things. You should create an index. And if you have HypoPG extension enabled, it tries to create a hypothetical index, and it shows you the explain plan before and with and without the hypothetical indexes, and it compares like the total cost and says like how much better it is. So on a cost-based approach, creating those two indexes should optimize your query by 63%, which is probably something you want to do. And if you take the exact same approach, but using on your whole workload instead of a single query, it can do the same. So it takes like all these queries and say like what are the predicates that seems like worth optimizing, and it does it, and it finds like creating those 4 indexes will optimize all those where clauses or join clauses, optimize all these queries, and for each query, it tries to create the hypothetical index and see how much it helps. And for almost all of them, it's like about like more than 50 or 60%. So it's just like you click on the button and 10 milliseconds later, you have this list. So it's very convenient for you to optimize rather than wasting your time for every one of them individually. Any questions so far? Yes?
Does HyperPG recommend any index other from B-tree, like G-in or bring like that?
So HyperPG doesn't suggest the index. It's either PG QualStat or PoWA. So it uses catalogs. Let me go back a bit. It uses a catalog to see what it sees. Like you have this predicate on this column has this data type, and use a catalog to see what index will actually help. So if you look here, you see like somewhere here. Oh yeah, see with B-tree, and here you have green.
Oh.
So if there is some knowledge in the UI to see like if B-tree is available, it tries to go to that first. But if B-tree is not available, it will use whatever your catalog say you can use an index for. And yeah, but it shows you all the access method you can use for the index.
Yeah, I get it.
Oh, and another thing I forgot to mention is for the global workload suggestion. What it tries is try to minimize the number of indexes it creates by trying to privilege multi-column indexes, because it's better to have one index with 2 columns rather than 2 index with 1 columns. Any other question? Yes.
On one of the slides, there was a query with where clause that was split into few where clauses. Like, is it not a full query or how it works? So what are these where clauses? How they match to original query?
That's the where is the UI show where, but it can actually be a join. It just it means a bit of knowledge. So we have a join on client ID. So you have the client ID equal something from here, and then the client ID equal. There should be another client ID. I'm not sure where. And here you have the that command between something. And I'm not sure why some are duplicated. That's probably like a distinct or a where that's missing in the query, but that's all extracted from this on join condition and this where condition.
So it kind of propagates this where clause to the other side of the join.
Yes.
Oh, okay. So it's what physically was happening on tables.
Yes.
Oh, okay,
That's
cool.
PG_stat extracts the things from the instrumentation. So when if you have an explain plan, you see everything that's happening. So it's extracted from that and accumulate them. So then you can do statistic on that.
Cool, thanks.
Thank you. Any other question? So hopefully, I started my cluster like 26 minutes ago. So I should have some metrics available. So that the first component you arrive is the list of your servers. So you can choose just one. If you see here, so this is a compose file which is like one primary, one standby, and you also have a PG bench on the primary, PG bench on the standby, and the demo workload on the primary. So there is a bit of activity happening everywhere, but it's mostly on the primary that things are interesting. So it just show like the slides, the picture, the screenshot I have actually from the exact same workload. So it's you should find the same kind of information. So what I didn't show, if you have some interactive stuff, so you can reload the collector. For instance, if you add a new server, there is like a SQL function to create a new server. It's not added automatically because maybe you want to add it, you have to modify something and not apply. So when you're ready, you can just reload the collector. You can also force a snapshot. So if say like, oh, something was happening, you want to see right now what's happening, so you can force it and then reload it. And you can also force a refresh of the catalogs. By default, it's every month or something because it's a bit costly, and usually you don't like change all your database and everything so often. So it's easier to do it when you need it rather than something. You also have a configuration tab. So it shows you if the PoWA collector is running and if there is any error, and then you can click on each of your server, and it shows like what are the extension PoWA knows about, if it's like available on the remote server, if it's installed, if it's sample, the version that's installed. Same for the support extension. Sorry, the module and the catalogs with when there was refresh. You see template 0 is not accessible, so it cannot refresh it. And you also see all your configuration. So for instance, if you're wondering like what is your work mem right now, and right now the work mem is like 8 megabytes. So it's quite convenient. So yeah, if you go on the standby, for instance, you have the archiver and replication things. So as I mentioned, I have like a primary standby setup. So you can see like, I'm actually on the standby. So I don't have a replication connection because it's receiving the connection. There is no cascaded replication, but you see on the receiver side, there was a huge spike because when I started my cluster, it started with restoring a backup. So you can see the spike from here. And then you see like the workload happening gives a bit of bandwidth. And yeah, same. It's probably better to look at the primary. On the primary, if you look at the replication, then you see the other side. Now you see the sender side, and on the receiver side there is nothing, but here you see everything is okay. You have like one replication connection which is stable, so nothing is happening. There is like a few spikes on the replication. So the first one was when I restore the backup and something happening. The lag is like a few microseconds. You see most of the lag is from the flush. That's expected because it's all running on my machine, so it's a local connection. So Postgres exposes all the lag. So on the UI you have the three information. So the right lag is the time it's spent sending the whatever data was replicated to the standby server. So since it's a local connection, it's very fast. So there is no much to optimize here. It's like a microsecond. The flush lag is a bit more important. It's because the flush lag is how long it takes when you receive the whole record to flush them to this locally and have a laptop. So have an NVMe, it's not that bad, but it's not like a production grade server RAID 10 with like a BBU cache something. So if I wanted to optimize my workload on the replication, it shows me that the problem is the flush, which means I need better disk. And the replay, it's also very fast. That's mostly because it's OLTP workload. So the records are very small, so there's not much to be done. So here it says my problem is my disks are a bit too slow if you want to get something better. So if I go to the exact same TPC database, so I see the same workload happening. And yeah, that's the thing I was showing. So it's not done by default because it can be a bit costly because it try to fetch a lot of things and you may not want to do it automatically. But if you want, you just click on the button and it shows you the exact same thing, all the same indexes with HypoPG trying to do it, and that's optimizing all of this query at once. So it's very convenient as a DBA. You don't have to take so much time to do that one at a time. So again, you can look at the query. You see like if it's generating any wall, like my workload is simulating like a random change, which there are a lot and not really interesting, but that should, on your production server, that should be way less and more important. You also have a predicate tab, so that's where I showed what was happening. So here it says like one index will be known and will be good. And so here, to answer your question, it said like you could create a B-tree index and you can also create a Brin index. If I install the B-tree gist or B-tree gene extension, then it will also suggest gene and gist. But since it's integer, by default only B-tree and Brin and probably Bloom could be used, but the Bloom extension is not installed. And you can even dig a bit deeper. If you click onto the predicates, then you have even more information about it. So here it shows like the most executed value. So there is probably a problem here, or maybe it was null. But the idea is like if like 99% of the time the exact same constant you're using in your query, it means you can create a partial indexes. You can create index on table column where column equals something, and it can tell you yes, this would be a good idea to do that. So that's all of that combined together can help you to very quickly optimize your production workload. So if you have more question or anything, so the doc on the PoWA.readerdocs.io. The main repository is PoWA team, so I have a bunch of repository inside. You have PoWA archivist, which is an extension, the UI, the collector, Qualstat, Kakash, and all other stuff. And I put my blog and my Twitter if you have anything. Or if you have any question, if you want to add your own extension here, contact me. I will be very happy to do it.
Hi. I want to know, is there support for any alert mechanism?
Oh, no. It's a production, like a performance analysis tool. It's not really like a supervision. So there is no alerting or something. It's more like something is slow, you want to know why, and you look at it. So usually the user call you is slow, and then you look.
Okay, another one. Is there support for exporting some matrix so that we can use in Prometheus?
So if you want all the data set, you can export them at CSV. But
Okay.
also, if you need, it's just a bunch of SQL queries, so you can write them in Prometheus.
Okay.
I looked a bit into it, but Prometheus is a bit limited. It can't do what we need inside the UI, which is like when you have pgstat cache installed, the query is not the same, and I don't think like Grafana can do this kind of transformation. But
Okay.
other than that, it's just SQL in the end. So you can use Prometheus exporter, you can use Grafana, you can use something else. And the UI can also export the queries using, so you can just copy paste them and you should be good.
Okay, thank you.
Any question?
How much performance overhead does collecting this kind of instrumentation if you run it in production workloads? Like, is it noticeable and is it realistic to gather all queries everywhere, all load nodes,
The
etc.?
collection itself is almost free because everything is in shared memory, so there is basically no overhead. The overhead is in adding the extension. For instance, pgstat statements, if you enable it, it's around like 1 or 2% overhead. If for some reason you have like an infinite number of normalized query, like if you use a lot of temporary tables, then you will have eviction in pgstat statement, and then pgstat statement will become expensive. So the overhead is the stat extension. The collection itself is basically free. It's every 5 minutes you select stuff from pgstat statement. That's not much on this side.
Thank you.
Does PoWA support some kind of like you are not there's a common question about you create too much index. So does PoWA suggest any index you can drop or?
So usually dropping an index is not always that easy because like you have to check it's not a unique index because it's more than an index or a constraint like a primary key index. But I don't think we added that yet, but now that we have the catalog, if you go to the database object, we now have enough information to know if there's an index, when was number of time you actually scan it. And if you see like this hasn't been scanned in 2 years, and it's not a primary and a unique index, probably you can drop it. So that's something you can add very easily, and that's a very good suggestion. So
Yeah, and also does PoWA support some kind of like how many hard update you are doing in your table?
The information is available. I don't think. Oh yeah, it's here.
Oh yeah. Very cool.
So yeah, the information is there now. That's only in PoWA 5.
Also, does PoWA support like PG state IO or?
Yes, that's. I think it's only on the per query stuff. It's probably somewhere here. Like I did so many graphs, so I know I have the.
Yeah. Anyway, yeah.
So I know I have the metrics. I don't know if they're in the graph, but if you want it, I can. We're just writing a SQL query and I did a widget, so it's easy to do.
Any question? Okay, thank you.
Thank you very much.